Hello, in this video, I will explain to you on how to find Ix using superposition. So our goal here is to find out what is Ix. And Ix is the current that pass through this 15 ohm resistor. Okay, and we need to do superposition, and what we need to do first step is to split the circuit. So split the circuit according to the number of independent sources. Split the circuit. So here we have a voltage source which is 3.5 volt and this current source which is this 2 ampere. So we need to split this into two circuits, and in each circuit we turn off one of the sources. So we need to turn off sources. And how to turn off sources? If we have current source, we replace it with open circuit. And then if it is voltage source, we replace it by short circuit. And maybe let's redraw the splitted circuit here. So the first thing that I need to do is I want to turn off this 2 ampere current source. So we replace this by open circuit, right? So we will replace this by open circuit. So I don't need to draw them. So we will only have this side of the circuit. So we will have that 7 ohm and 3 ohm in series. Like this, 7 ohm. And then we will have that 3 ohm in series. And then we will have that 15 ohm here, have 15 ohm, and then we also have that 5 ohm resistor like this, and we still have this voltage source, so we will have it like this. So this is 3.5 volt. And then that is it. Yeah, this is the first circuit, the first splitted circuit. And then the second one, I need to turn off this one here. So this is a voltage source, so we replace it by short circuit, right? So we replace it by short circuit. And let's redraw the circuit here. We still have that 2 ampere current source. So we will have it like this, 2 ampere. And then we have the resistor here. We will have that 7 and 3. 7 ohm, and then this one is 3 ohm. 7 ohm, and then 3 ohm here. And then that will be 15 ohm. So we have 15 ohm here. And then we have this 5 ohm resistor, but this is shorted. So all the current will pass through this one and not this one. So we can just replace this 5 ohm by open circuit. So we will have it like this. Right? And so this is the two splitted circuit. And here we label all the target here with Ix. This one is Ix prime, and then this one will be Ix double prime. Good. And Ix double prime is the current that passed through this resistor. And what we need to do next is to do analysis on both circuit. Do analysis on both circuit. So we need to find out what is Ix prime and what is Ix double prime. So our target here is to find out Ix prime and then Ix double prime. Good. Okay, maybe let's clean this up, and we need to do circuit analysis here. Okay, now let's do circuit analysis on this first one first. So if we set this here as our ground, so the voltage here will be 0. we can get that this node here is 3.5 volt, right? Because this is a voltage source. So we know that this node here is 3.5 volt. Good. But then we can calculate Ix here. How to do that? We can use Ohm's law. So we can calculate what is Ix is. Ix prime here is equal to, because the current is flowing from the ground to the 3.5 volt node, so we will have 0, where the current came from, 0. And then the current goes to here, 3.5, so I will have minus 3.5. And then it is divided by the resistance between them. The resistance between them is 3, 7, and 15 in series. So I will have 3 plus 7 plus 15. And so we will have minus 3.5 divided by, what is it? I think that will be 25. Good. And I think I will just leave it into calculator. Okay, what is it? I will have minus 3.5 divided by 25. And that will be minus 0.14. Minus 0.14. And the unit here is ampere. Or to make things tidier, I will have Ix prime here is equal to minus 140 milliampere. And that is for Ix prime. Now we need to do analysis on this circuit here. Okay, let's set this here as our ground. And then let's make this here as node A. Okay, and so this current here is 2 ampere there. And let's assume the direction of the current is goes here. What can we do? We can do KCL at A. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. So here we will have the current that goes in, that will be 2 ampere. And then the current that goes out, I will have VA minus 0 divided by 7 plus 3. And then I will have plus VA minus 0 divided by 15. Good. And I will have 2 is equal to, maybe let's take VA out here. We'll have VA over 10. And then we will have plus VA over 15. Good. Multiply both sides here by 30. And we will have, what is it? 60. And this 10 and 30 will cancel into 3. So we'll have 3 VA and then plus 2 VA. Or 60 is equal to 5 VA. And then we will have VA is equal to 12 volt. But then if VA is 12 volt, we can calculate Ix double prime. So what is Ix double prime? That will be 12. Here, this is 12 minus 0 divided by the resistance between them, which is 15. So we will have 12 over 15. And 12 over 15, let's just use calculator, 12 divided by 15. And that will be 0.8. So we'll have 0.8. And the unit here will be in ampere. So this one will be in 800 milliampere. So now we have Ix prime is minus 140 milliampere. And then this one will be 800 milliampere. Good. And what can we do next? We can just add them up. So we will have to add them up. Okay, maybe let's clean up our slide first. So the question is asking us about the original Vx, Ix here in the original circuit. And we can just find it by using the formula Ix is equal to Ix prime and then plus Ix double prime, right? Because this is from our splitted circuit. Ix prime is this one and this one is Ix double prime. And we know that Ix prime is minus 140 and then Ix double prime is 800. So we will have our Ix is equal to, I think I will use calculator here to avoid any mistake. So we will have minus 140 plus 800, that will be 660. And the unit will be in milliampere, right? Because both of them is in milliampere. And finally, we have achieved our goal here, which is to find Ix. And that is 660 milliampere. So that's all for this problem. Hopefully, I did not make any mistakes in the calculation. Thank you for watching. See you in the next video. Bye-bye.